So still want to start just like we did last day. Where is it equal? So it looks like I get a value of 0 where it's equal. What's the other value that I need to include here? Yeah, so -2 is the asymptote. That's one that we're going to be concerned about. So let's look at a region from -2, 0. Okay. And this time, we can't just talk about positives and negatives because we're not comparing it against 0. We actually have to check a value in that one of those intervals. So for example, one simple value would be, say, x equals 1. Then I would get 1 minus 4 over 1 plus 2. So -3 over 3, which is -1. So is that greater than -2? Yes, -1 is larger than -2. So this is one of the places where I'll have a solution in this area. Okay, then we'll check again over here. So if we want to do it, maybe we pick -1 this time. That'll be -5 over 1. Is that greater than -2? Nope. It's a bigger negative, but bigger negatives are technically smaller. Okay, so the last one, maybe we would try something like -3. So -3 minus 4 would be -7 over 1. Sorry, -1. Thank you. So that'll be a +7. So is +7 greater than or equal to -2? Yeah. So this region also works. Okay, so remember, this is the asymptote here, so we cannot include it. But my solution would be x must be less than 2. Sorry, -2. Or x can be greater than or equal to 0. So the reason that we're not just looking at positives and negatives is positives only tell me if they're bigger than 0. Negatives tell me if they're less than 0. Now I'm comparing it against -2. Okay? So let's try this one over here. Same idea. Remember, you're not comparing it against 0, so you'll have to actually put the numbers back in for the regions you find. Okay, so you can start checking your work over against mine. Did I? Oh, sorry, yes, it should be a -1/2. Just clean that up there. So that'll be 1 over negative 0.5. Is that greater than 2 over...
1 over negative 1.5.
Okay. And that'll be just 0.5. So that's not true because this will be negative 2. Is that greater than 4? No. So the last one, maybe I'll try negative 3. So that'll be 1 over negative 2. Is that greater than 2 over negative, 1? So is negative 1/2 greater than negative 2? Yes, it is. So that one would work as well. This is my asymptote here, and this is my asymptote here. So I have to reject those parts of it. So it'll be x must be less than 2, negative 2, or it's going to be between negative 1 and 0. So don't include negative 1, otherwise it's going to divide by 0, but everything up to 0 is also okay. Okay, so it's a very similar pattern to what we did with absolute values as far as find the boundary and test whether the regions are larger or smaller. So hopefully there's some overlap there. Yes? Sorry? Let's see here. Oh, right, because it's strictly greater. Thank you. It's strictly greater. There's no equal sign this time, so it can't be equal to the 0. Otherwise, that would be where they are equal. Good catch, Jackie. I was doing so well first block. Okay, so this time around, you're going to have a couple more boundary points because of the quadratic equation that comes out of it. So let's see, we get x minus 1, x minus 2 has to be less than or equal to 6. And we're going to take that less than or equal, and we're going to look for where it's equal to 6. So x squared minus 3x minus 4 equals 0. That means x minus 4 plus 1. So that gives me a couple boundary points, one at 4 and one at negative 1. Those are where it's equal. Okay. What else needs to be included here?
2.
Yeah, I also have to include at x equals to 2. That's where I get the asymptote here. Okay, so now
1 though.
that doesn't cause a division by 0 in number 1, right? If I put in x equals 1, everything is still okay.
Yeah.
It'll fall into one of the regions that we end up with here. Okay, so we've got negative 1, 2, and 4. And if we check some of the values, for example, there's a good one. Let's put in x equals 0. Then that means is negative 1 less than or equal to 6 over negative 2? Negative 1 is not less than negative 3, so this is not one of the places I'd like to find a solution. If I put in, say, x equals 3, is 2 less than or equal to 6 over 1? Yes, 2 is definitely less than 6. Okay, and so we'll finish off, check at x equals 5. That will be, is 4 less than or equal to 6 divided by 3? No, 4 is not less than or equal to 2. We'll try another one over here. How about negative 2? Is negative 3 less than or equal to 6 over negative 5? That is true. So all that's left to do now is to make sure that I don't land on an asymptote. So I'm going to put a circle here and then write my solution, which would be all values less than negative 1 can also be equal to negative 1, or all the values here, which go from 2, but not including 2, otherwise I divide by 0, up to and including 4.